Okay, this one might take a little longer. This is off of one of the most recent regions, so this may be an indication that you should expect something a little challenging on this year's regions when it comes to organic questions. I personally would not shy away from giving you a question like this on a part two. Part of the advantage that you have is that I've given you the questions in advance. So let's run through what they've given us and what we're looking for. So we're looking for the general formula of the homologous series to which these compounds belong. General formulas for the homologous series is the exact phrases you will find on table Q. Table Q is the table of homologous series for hydrocarbons, and it contains a column called general formulas. So make sure you've got table Q out for this question. The next thing would be for us to look at the table and see which class of compound are we in. Two, state in terms of strength of intermolecular forces why boiling point of one substance is lower or higher than the other one. And that means we're going to have to refer to some of our prior knowledge about the strength of intermolecular forces and how that impacts boiling point. And then look at the boiling points because they gave you a column where they gave you the boiling points. And number 78 in the space in your answer booklet. So here is the answer to the question, will they ask you to draw things? Yes, they will. They will ask you to draw isomers. They will ask you to draw structures. They will ask you to name structures. So you have to be able to draw these and you have to know what you're doing. So you're going to have to draw a structural formula of the third pentane isomer to methylbutane. Now, the thing that they've done as a favor for you here is that they told you what the isomer was. They didn't make you come up with it on your own. You just have to draw 2-methylbutane. So you have to be able to draw 2-methylbutane. All right, so let's start with the first one. Write the general formula of the homologous series to which these compounds belong. So one thing that I would recommend to you in terms of reading comprehension and working yourself through a question is make sure that you've got a logical order that you go through this in. So I sometimes go to the end of the question first. So write the general formula of the homologous series. So I have to identify what homologous series this is before I can write the general formula. So it doesn't tell me in the question the steps I have to follow. I have to figure out what they want from me and make that determination on my own. So the homologous series these guys belong to, you're going to, if these are hydrocarbons, they both are, right? They don't contain anything but hydrogen and carbon. And they have all single bonds between their carbons. So you should have an inkling that this is going to put them in the category of alkanes. So this literally says copy the general formula off table Q for alkanes. So there's actually not a whole lot of skill involved here. Then you have to ask yourself, what are they really testing me on? They're testing you to see if you understand what are hydrocarbons and how to classify a hydrocarbon into one of the three categories. So if you can successfully look at this molecule and decide it's an alkane, they're saying you're successful at doing that classification. If you can write this, sorry, my terrible handwriting, CnHn H2N plus 2 is the general formula for alkanes. You just copy it off of table Q. They weren't testing you on whether or not you memorized it because it's on the reference table. They were testing you on whether or not you could tell that this was an alkane. Okay, now state in terms of strength of intermolecular forces, why the boiling point. So this is, most of this whole phrase is not important. They want to know, you can cross these compounds out. Okay, what they want to know is can you tell them how strong intermolecular forces are when boiling points are low versus boiling points are high? That we've been talking about since the very beginning of the year. If something has a very high boiling point, that means the particles in that substance are very, very attracted to each other. They have high intermolecular forces. So you have to put a lot of energy into that substance before you can make it boil because boiling leads to vaporization. Vaporization is when something goes from a liquid to a gas. If you want particles to spread out, right, let's draw it really quick. because right now you might already be spacing out on me. So if I've got a liquid, my particles are pretty close. If I want them to boil, they're going to go to a gas, right? If my particles are far away from each other in a gas, that means I have to overcome the force of attraction to pull them away from each other. And that's why I have to put in so much energy. When I have to put in a lot of energy, it gives me a high boiling point. Now, they have asked you about the low boiling point. Low boiling point means the opposite. It means that your intermolecular forces are weak. So I'm going to put. Now, the only reason I would need the name of the compounds is to make sure that I refer to the correct compound. Intermolecular forces in dimethyl propane are weaker. That's all I have to say. But I don't want to not say which compound I'm talking about because you want to make sure that you've really addressed what they asked you about. They asked you why is the boiling point lower in this compound. So you want to make sure that you say that, but you want to work on being as concise as you possibly can be. All right, last but not least, we're going to draw this isomer, but I didn't have to actually figure out what the isomer looked like. So if you have to figure out an isomer for yourself, you have to try and draw a structure which has the same molecular formula, but that you've actually drawn a different structure. This is tricky. And so to help you out, it looks like they didn't make you figure out the isomer part by yourself. They just said, hey, these are all isomers of each other. So these are all actually isomers of each other. Hold on one sec. So pentane and dimethylpropane are isomers of each other. They're saying there is a third one. These are two isomers of pentane. There's a third isomer. You're going to draw it, but you don't have to figure out what it is. They told you what it is. It's 2-methylbutane. So basically, all they've left up to you here is can you figure out, oh, that's slow. Can you figure out how to draw 2-methylbutane? And that makes your life a lot easier. Hopefully, you've been paying attention and you can draw methylbutane. All right, so 2-methylbutane. So I'm going to follow my rules for branched hydrocarbons. In a branched hydrocarbon, I am going to first draw the parent chain. So my parent chain, why are you not cooperating with me? Oh, my parent chain is butane, so that's 4 carbons. Then it says I'm going to put a methyl group. I'm going to put that methyl group on my second carbon. 1, 2, 3, 4. 1, 2, 3, 4. So I could put it here or I could put it here. It doesn't matter. That would still be the second carbon. So you guys tend to want to go left to right. So I'll put it here. That's a methyl group. Everybody else gets hydrogens. Stop it. Everybody else gets hydrogens until you've got 4 bonds on every carbon, and that's 2-methylbutane. And you're done. So you are going to put the hydrogens. Please make sure you draw a completed structure the way that they drew it in the question. All right, that was quick, you guys. We're done.